In this video, we will explore what a confusion matrix is. We will look at the important concepts related to confusion matrices such as misclassifications and their types, false positives and false negatives. We will also look at true positives and true negatives and see how they build a confusion matrix. This is an introduction, so we don't have any recommended prerequisites for this video. Consider we have a model that classifies inputs as positive if they are green and negative if not. In this example, the model takes 5 inputs where the first 3 are positive and the last 2 are negative. The model classifies the first 2 as positive, the next 2 as negative, and the last input as positive. The model made 2 misclassifications. Input 3 was misclassified as negative when it was actually positive, and input 5 was misclassified as positive when it was actually negative. Do these 2 errors represent the same type of misclassification? What kind of misclassification is prediction 5? The model falsely predicted a positive when input 5 is negative. Prediction 5 is a false positive. A false positive can also be known as a type 1 error in statistics, false detection, or a spurious detection, as well as a false hit, false alert, and false trigger. A common example of a false positive is in enemy detection in the defense industry. Models used to distinguish enemy aircraft may misidentify a friendly plane and prepare to shoot it down. Alarms then go off due to a possible bombing threat. Only when the plane is within firing range do you realize it's friendly. Your model triggered a false alarm. What kind of misclassification is prediction 3? Prediction 3 is a false negative. The model incorrectly predicted negative when it was really positive. False negatives are also known as a miss in radar and detection, type 2 errors in statistics, as well as false dismissal, undetected positive, or a missed alert. Which one is more critical to avoid? A false positive, type 1 error, or a false negative, type 2 error, and why? It depends on the use case. For example, if we have a system to screen for a life-threatening condition at an early stage, a false negative, a miss, will send a sick person home. However, a year later, it became clear that the screening result had missed the condition. The trade-offs of prioritizing fewer false positives or fewer false negatives will be discussed in later sections. To recap, early detection is critical. False negatives can be catastrophic as they fail to identify severe cases. However, if an enemy aircraft detection system produces a false alarm, it could lead to shooting down a friendly plane, which is costly. So what are true positives? Those are correctly predicted positives. In our initial example, predictions 1 and 2 match correctly with the actual positives. On the other hand, true negatives are correctly predicted negatives. In our case here, prediction 4 was the only one correctly predicted as negative. Now let's see how our findings form a confusion matrix. When predicted and actual cases both are positive, it's called a true positive. We found 2 such cases. When predicted and actual cases both are negative, it's called a true negative. We found 1 such case. When an actual negative is predicted as positive, it's called a false positive. We found 1 such case. When an actual positive is predicted as negative, It's called a false negative. We found one such case. With that, we have a confusion matrix. A confusion matrix helps you see how well a classification model makes predictions by showing counts of true positives, false negatives, true negatives, and false negatives that are output. A confusion matrix is the foundation for many classification metrics. Precision, recall, and F1 score are computed directly from it, while ROC area under the curve and precision recall area under the curve are derived by aggregating results from confusion matrices generated at different classification thresholds. We will discuss these metrics in detail later. Before we wrap things up, here is a brain teaser. Given this 3x3 confusion matrix, how many false positives, true negatives, and false negatives are there? We would love to read your answers in the comments below. Also, don't forget to subscribe. It motivates us to create more content for you. To recap, we have explored how to construct a confusion matrix and its purpose in training models. Now, you have an introduction to confusion matrices under your tool belt. If you would like to learn more, I suggest looking at our classification matrices and class imbalances videos.